Welcome. Myself, Pakri Hazra, Assistant Professor at Kotakali Science and Technology University, Bangladesh. After this video, you will be able to understand and evaluate Action Plan for Energy Efficiency and Energy Conservation 2013. The government of Bangladesh has adopted the Action Plan to consolidate efforts and coordinate different energy efficiency and energy conservation programs and measures towards achieving a set of national targets under a single government umbrella through establishment of Sustainable Renewable Energy Development Authority. The action plan will also recognize energy efficiency and energy conservation measures, programs associated with sectoral and national interest, putting emphasis on government priorities. It is also expected that those interventions will be further accelerated by both government and non-government stakeholders through a variety of possible ways. In continuation of this action plan, comprehensive study on sectoral energy efficiency status will be conducted for preparation of a master plan on energy efficiency management with a view to exploring the prospective areas of energy savings in different tiers, which will be commencing subsequently to meet the specific targets. Vision of the action plan. Government has stated vision of improving the primary and secondary energy saving level for sustainable energy security, including low carbon emission. And the mission is in line with its vision statement. The government has set target about 20% primary and secondary energy saving by 2030 to ensure the sustainable energy security. There are four identified categories of action plan for energy efficiency and energy conservation, such as the energy efficiency in power generation, energy efficiency in transmission, energy efficiency in power distribution, and the demand side energy efficiency. Let me first talk about the different initiatives or interventions for improving the energy efficiency in the power generation sector. The first intervention is related to rehabilitation of the old and inefficient power plants as per the policy guidelines for enhancement of power participation in the power sector. Replacement and repowering of the power plants that are still running at very low efficiency and their availability beyond their economic lifetime. To take possible energy efficiency measures, each power plant must have a responsible technical person who will identify the possible energy loss and take measures for the prevention of the same in the power station and assist the energy audit system in the power sector. This person should be trained and strengthened to perform the job responsibly. Timely procurement of spare parts and adhering to the maintenance schedule must be followed by all the power plants for keeping the plant operational and standard level. In-house capacity building and proper training of the operation and maintenance people of the power plants as per standard practice. Online interface meters are to set up the energy dispatch point from the power station to the grid to monitor the energy generation. All the new coal-based power plants are to be designed with supercritical boilers and gas-based simple cycle baseload power stations as combined cycle ones for higher energy output. The peaking power plants will not be allowed to run in base load to avoid the unscheduled heat loss. Several improvement interventions have taken for energy efficiency in the power transmission sector. The first one is power factor and voltage drop. There are currently two voltage regulation projects underway which will rapidly improve the line losses. This will add approximately 950 megawatt ampere of capacitor banks and reduce line losses by 128 gigawatt per year. Then the second one is prevention of forced outage, blackout, and synchronization mismatch. There are some mismatches in current level of fault setting of the large substations around Dhaka. This could lead to system intervention and blackout. Power Grid Company of Bangladesh (PGCB) should identify the substations and take necessary corrections and replacement of undersized protective device for smooth operation. The third one is upgradation of line and transformer capacity. PGCB should identify the lower loaded transformer and transmission line considering the future demand generation growth. Then the automatic generation control, smart grids and system metering. PGCB should regularly evaluate the economic load dispatch merit order, current load dispatch system, and identify the proposed measures to be adopted to enhance energy efficiency. This will include automatic generation control in supervisory control and data acquisition system, smart grids, proper system metering, etc. In-house capacity building and human resource strengthening measures. The PGCB will identify the possible training programs to promote in-house measures in transmission network operation and maintenance. Islanding the grid connectivity. PGCB will introduce the islanding the grid connectivity of managing long-distance grid lines and for efficient management of the grid loss. Several interventions have also taken for energy efficiency in the power distribution sector. Upgradation of distribution lines and substation. Distribution utilities will identify the areas with lines and substations overloading and issues concerning load distribution and feeder lines and prepare a priority list for replacement and financing. Load balancing in the distribution areas should be followed. Power factor improvement. Power distribution utilities will assess the current distribution power factors as well as prepare action plan and take necessary measures to address this issue. Modern metering and service drop. Distribution utilities will adopt standard service drop practices and proper metering system. Each power connection should have proper metering, preferably prepaid meters of low tension consumers and remote metering for high tension consumers and billing system. Prevention of leakage and in-house capacity building. Distribution utilities will identify possible leakage prevention measures and proper training to enrich in-house capacity building of the personnel servicing in the sector. In Bangladesh, there is a widespread prevalence of low-cost, less efficient, and higher energy-consuming equipment which do not take into account the life cycle cost, particularly where the energy cost component is very low and subsidized, often in buildings where the insulation and energy saving measures are overlooked deliberately to save cost by the developers. The end users unknowingly suffers from higher energy cost over the time. There are several demand-side energy efficiency programs in Bangladesh. For example, one is demand-side management through metering. Interaction of meters in various spheres can effectively add to demand-side management of power consumption and contribute to saving a good deal of power in many ways. This additional power can be used for peak time compensation and for diverting the industries. The identification of energy inefficient equipment and appliances. By taking appropriate steps through imposing restrictions upon the production, importation, and identification of energy inefficient equipment and appliances. This will contribute significantly to energy conservation in the country. Bangladesh Air Standards and Testing Institutes (BSTI) will play a key role in standardizing equipment and appliances in the country. Also, there needs to be sound monitoring of the import of electrical appliances to ensure that no old energy inefficient technologies are brought into the country. Demand saving program. More recently, the government has taken initiatives to control the consumption of electricity in the public and private sector. For example, the government estimates that a saving of around 350 megawatts of electricity has been achieved by undertaking actions like keeping the urban shopping malls and shopping centers closed after 8 p.m. Energy efficiency in the construction sector. The energy efficiency and sustainability section of building code is aimed at enhancing the design and construction of buildings through the use of concepts having positive environmental impacts. Sustainable construction practices involving energy efficient bricks, encouraging efficiency and conservation of energy, water, and building materials, and also promoting resource efficiency. It proposes both mandatory and voluntary measures for green buildings. In future, the SHREDA is in consultation with the relevant organization will identify the possible areas of incentives and provide certification for green buildings. The CFL and LED distribution program. The government has already carried out the CFL distribution program all over the country with the support of World Bank. In the meantime, the LED is considered to be more energy efficient and already in the market. Power distribution divisions or SHREDA will consider undertaking similar program to promote LED in the country. Awareness raising program will be continued for the use of energy saving bulbs including CFL and LED, etc. The street light program. The government is considering the replacement of street lights by LED. Already a few streets in Dhaka have been converted to solar street lights for showcasing the effect through public-private partnership. Conventional street lights will be replaced subsequently by LED or solar lamps in phases. The government also has a plan to discontinue the production of incandescent bulb in near future to support the above program. LED security lighting in urban areas. To reduce the large peak demand for lighting in the night time, LED security lighting will be introduced in the urban areas. Power utilities will conduct public awareness program to install solar or LED security lighting system in industrial, commercial, and large housing areas, preferably powered by solar system. Commercial and industrial fluorescent light relamping program. Replacement of magnetic blast set of T8 4-feet fluorescent light with latest generation electronic blast energy saving type TH 18mm 4-feet fluorescent light set can save an average of 11 watt per lamp and also give relatively more light output. Replacement of magnetic blast with latest generation electronic blast can also save an average of 7 watt per lamp. The replacement program is already going on in large industries and domestic complexes. Okay, that's all for today. Thank you for watching the video.